Hi, welcome to the Calculus 2 lecture series. And we are in unit number 2. And this unit, we're going to talk about all the different techniques of the integration. So this is a lecture number 9. So in this lecture, we're going to discuss another special technique. We call this the partial fraction. So basically, we're going to take a look at how do we do the integration of rational functions by using the partial fractions here. So so let's go ahead and start. And for here, let's go to our lecture notes here. Okay, so the key concept for this lectures here, we're going to cover the 3 things. And so the first thing here is we want to evaluate the integrals. Okay. Let me write this here. You value the integrals, and these integrals are containing the rational functions. Okay, and then we're going to introduce by the partial fraction. So this will be our first topic, and we're going to use 2 videos to cover the first topic. So we're going to talk about the method, how to determine the constants, the coefficient of those partial fractions. Then we also have one, the second video we're going to talk about is how to really carry out the evaluation. Then the next topics here, we're going to talk about 2 very special integrations. So we're going to take a look at how do we do these 2 special integrations. Okay, so 1 over x squared minus a squared dx. Our previous lecture number 9, we know how to do if you have a square root, right? So if we have square roots of x squared plus a squared, or square roots of a squared minus a squared, then we can use the trig substitutions. Correct? Okay, so we're going to take a look. How about now I don't have the square root. Now, what type of how do I use the partial fraction to help us solve these problems here? Then the last topics here we're going to talk about is evaluate the integrals. Okay, using there's another substitution we call it is rationalization, or we call it rationalizing substitution. So we kind of gradually expand from the U-sub and the trig substitution, and then now we have a rationalizing substitutions here. So basically, for whole this lecture number 9, we're probably going to have 4 videos. So we're going to have 2 videos for this one, and 1 video for this one, and probably 1 videos for this one here. Okay, so what is the steps to break into the partial fractions? So remember, right? So we said now we have the rational functions here. So what do we mean, the rational functions, right? So the rational functions, so we talk about the rational functions. That means you have a function in the form of the px, qx, something like that. And both are the polynomials. Okay, so both are the polynomials here. So the partial fractions basically, so is we rewrite this into a sum of several partial fraction or the rational function. Then those, when you after you rewrite it, those rational function, you know how to take the integration. Okay, so when we do that, we have a few key steps. Then we're going to take a look, how do we break it, all right? So the step number 1 here. Okay, so let's take a look here. So the step number 1. Okay, so the step number 1 is if the degrees of the px is greater than the degree of the qx is greater than or equal to the degrees of the qx, then what are we going to do? Then you use the long division. I hope that everybody still remember long division. Well, that's what you learned from the algebra, right? Then you use the long division to rewrite. Okay, so you will rewrite this is the px qx is equal to the h of x plus the rx qx. Okay, so now the rx and the qx here. So after you rewrite this, so the degrees here, the degree of the rx is what is less than the degree of the qx, right? That's what is the long divisions taught about to do. Okay, so let's see. It's that is the first step here. Then the second step is what do we need to do here? So we will rewrite, right, the qx, okay, in a factored form. That means that I want to factor the form, and as a product of powers of a distinct linear and we call this irreducible quadratic. The irreducible is, that means not be able to factor anymore, right? Not able to factor the quadratic. So for examples here, that's what I mean here. So for example, if you can, the qx, you can factor like the x minus 2, 3x plus 1, and then maybe this is the x squared plus x plus 2 here. That's what I mean. You factor that into the product, right, of the linear. So when we talk about, when we say the linear here, okay, so the linear, that means this is what we call is linear. Then the quadratic, this is the term we call is the quadratic here. Okay, and then we are set them. So the step number 3. So basically you can, so basically you try to write, because right now is the rx qx, right? So you will rewrite it into some factored form. So this is a t1x plus t2x and plus tnx. I don't know how many terms we have here. So after you do that, so you will try to rewrite it in this way here. Then the last step here. So the last step is step number 3 here. Then we are going to solve the T1, T2, and the Tn's here. Okay, so that is the step, and we're going to take a look at some of the problems, and so we be able to follow this step. So in here we have 4 different cases we can use to break it. Okay, so the first thing is here. Then we want to see type of the QX factor and the corresponding TIX. All right, so what I mean here, take a look here. Okay, so the first one's here. All right, so if you have some linear like x minus a just by itself here, then the corresponding, the TIX will just be what? So your corresponding will be, this is x minus a. So you always remember the Rx has to be less than, right? So has to be less than the degrees of the QX. So you will have, you just put a constant a here. How about after you factor? So the second case is here. The second case will be, all right, so if you factor the x minus a to some type of the power, so could it be the third power, fourth power, so the way I, try to break it, then you will need to break it like into, this is what we mean the partial fractions here. So because this is x minus a, so this is x minus a, then you have x minus a square and to the x minus a cube case, right? And then for each one here, you still have a, b, c, or well, instead of a, b. So let's do this maybe. So it's a1, a2, to a case, right? Okay, so that's why when the step 3 we say solving that means I need to solve those constants here. Okay, so the next things here, how about if after you factor your QX is quadrated? So that means it's ax squared plus bx plus c. You cannot continue to factor this down to the next level. Then what is your TX will be? Your TX will be like ax squared plus bx plus c. Now, what is the top here? Because this is quadrated, right? So you're going to go down 1 degree. So you will say here, let me put the correct color. So this will be you going down ax plus b. All right. So the x plus b, because you remember the Rx here, right? The degrees of Rx should be less than your denominator. Okay, so then the next terms here is how about you have ax squared plus bx plus c to the case power. Now, how do I break it? Just like the second one. All right, so this will be ax plus bx plus c. Then this is ax plus bx plus c, I'm sorry, square. Then this is the square plus ax squared plus bx plus c to the case power, right? And then your top will be what here? So you will be a1x, still is 1 degree less, right? Plus b1. Then this is a2x plus b2, and to the akx plus bk. Some of you might ask, you say, hey, you said it's less than, right? So like for here, for example, for these terms here, this is x minus a square, right? So the highest degree is x squared. Why don't I use like a2x plus b? Right? So why I only need to use A2? The reason why is when you try to add all those fractions, right? When you try to add all those fractions, then for the common denominator, then they will already, so like for the x minus a to the case powers, right? So you will have the, the k minus 1's power from for example, for the first term, because the common denominator, then this one will be something like x minus, so this will be something like x minus a to the k minus 1's power for the first term. So that's why you're going to have the higher order term by the common denominator. So that's why you don't need to. So you just need to still, you have the constants here. All right, so just like in here, this is ax squared plus bx plus c, right? So the one term lower is linear. So that's why I have a1x plus b1. So even for here, right? So this is the ax squared plus bx plus c to the second. Why I still use the linear term? Because when you try to find the common denominator, the other terms they're going to cover, you know, you said, okay, this is the highest one is x fourth, right? So where is x cube? It will going to be covered by the other term because of the what? The common denominators. All right. Okay. So now if you're still confused, let's take a look at some example. I think that will help you to clarify. Okay. So the first one's here. Okay. So this one's here. They said, let's just to rewrite it and we don't need to solve it. So the second video for this topic, we're going to take a look at the problem. But in here, let's just try to see what we have here, all right? Okay, so let's see here the first. This is the denominator and this is numerators, right? So the numerator, this is what? The highest power is what? Is 2x, right? So it's x is the first power. Then this is x times x is x to the what? Square. So it's good. We don't need to do anything. It's because this power is less than that. Okay, so now, you know, the qx is the factor for these two terms, right? So x and x minus x plus 8. So both of them, they are the linear term. So I know I can break it based on what? You know, based on the case number ones, right? So I can break it into a 2. So I can say this is x plus 8. Right, I break this one, then the top here, I can put a constants A and the constants B. Then I can integrate. So now if I'm integrating here, right? So if I'm integrating here, that means I can integrate here. So did you see how easy? Then this is a natural log x, right? Okay, so that's what we're going to do in our second video to take a look at how do we really integrate it. So after you rewrite it, then we need to solve. That's what we said step number 3. So we need to use the algebra, find a common denominator. So our job is to solve A and B, right? So probably we need to use what methods here. We need to use the system of equations, right? So we're going to solve it. And then we're going to take a look in our next video how to solve it, right? Okay, so now let's take a look at the second one here. So the second one, so here the highest degree is 2. Now here is x squared, so it's x fourth. So that's good enough. I don't need to do anything. I don't need to use long divisions. Okay, so here, let's take a look at the first terms here. The first term is x squared, x plus 1 to the square. And the second term is x squared minus 3x plus 5. So be very careful here, right? So this is the x what? X squared is repeat, right? So now if I do that, so how do I break it? My x, so I will need to have x plus 1 because it's x squared. So I need to break it x plus 1 to the what? To the square, right? Then the last terms here, x squared minus 3x plus 5, I cannot factor anymore. So this will be x squared minus 3x plus 5. Okay, and now in here, let's take a look. So this is what? This is linear, right? So I put an A. And do I need to put a bx plus c? No, because this is a repeat of this one. So I will put b here. Okay, so for this one, the highest term is quadratic. So what I need to do here, I need to go 1 degree down. So it will be a linear. So I will put a cx plus what? Cx plus d. Then we need to solve A, B, C, D, right? So we need to solve A, B, C, D. As you can see, in order to solve A, B, C, D, I might need to solve 4 equations, right? So four equation in my system. So sometimes will become a little tedious, right? So you probably need to have 4 linear equation and I need to solve it. All right. So now let's take a look at the third ones here. So the third one, okay, the numerator, the degree is 0, and here this is x squared, the square, so it's 4, so it's fifth. So bottom is higher than the top, so that's good. Okay, so let's take a look at this is the first factor I product, and this is the second factor I product, right? So my qx, so this is the squares, right? So follow the square rule. So here, what I have here, the first I have x plus, so this will be x squared plus 2x plus 2. Because here is a square, what I need to do, I need to bring the next term. I need to go down each power till the end, right? So this is the square. Okay, so now let's take a look, the constant. So this is linear, right? So what is my constants here? It will be A, right? So this is x squared. So the highest one is x squared. So I need to go 1 degree lower. So what I have here is bx plus c, right? And this is the repeat. This is a square of this. So I still just go the once 1 degree lower. So what I have here, I have a dx plus e. So as you can see, it's getting more and more variables. So now I need to solve what? Solve A, B, C, D, E. So very possible I'm going to have 5 equations with 5 variables. And that's why the algebra is extremely important and probably will be, the very tedious to solve. Okay, so let's take a look at these ones here. So for these ones here, the numerator is x to the cube, the highest power. The denominator is x to the square. Then you will say, oh, okay, so when we just, that if you go back to the steps here, right? So the first steps here, if the polynomial, the top is the degree is bigger than the bottom. So what do we need to do? We need to use the long divisions here. Okay, so let's take a look at the long division to see. We remember how to do the long divisions here, right? Okay, so remember the long division. So I need to have x cubed here. Then this is x squared plus 2x plus what? X squared plus 2x plus 1. So here, all right? Okay, so now here, this will be what? This will be x, right? Okay, so x, remember how to do long division? So x times x squared. So this is x squared, x cubed plus 2x squared plus x, right? So you use you use this number times each term, all right? And then what you do, you minus it, right? So x minus, so this one disappears. So this is 2x squared minus x, all right? Okay, so this is 2x squared minus x. And now you need to continue carry on to make sure it's less than the degree. So this one is -2. So you do the same thing. This is -2x squared minus 4x minus 2, right? So you use the -2 times each term. Then what you do here, you minus it. So these two cancel, minus x minus 4. So what is here? 3x plus what? Plus 2. Oh, yes, finally, what? Finally, this one here is less than the degrees here. So now, okay, so now this one's here, let's try to do here. I can rewrite this one is equal to x minus 2, then plus 3x plus 2 to the x squared plus 2x plus 1. Oh, I just noticed here. So this is x minus 2 plus, what is here? 3x plus 2. What is x squared plus 2x plus 1? This is x plus 1 to the what? To the square. So you will see here, you say, oh, okay, so this is x plus 1. And here's a square. So I said, okay, now I can write it into the partial fractions, right? So this is x minus 2 in the front. Then this first term is x plus 1. And remember, if they have a power, you just continue carry on till the end of the power. So this is x squared. And now here, because this is x plus 1, so what is my constants? A, right? And because of these are the same term, it just have a higher power. So I'm still going to just have a what? Use the lowest, the one term lower than the original. So what is here is a B, right? So for this province here, and what is the, so you are going to solve what? Is going to solve the constants A and the B. So you're probably going to have like the two equations and two variables to solve it, right? All right, so that is for the first video for the technique about what is the partial fractions mean. And so just be careful when you factor your denominator, then you try to break the denominator into several fractions. And when you break these ones here, then you can take the integration easily, right? So just be careful, like if it's linear in your factor, well, I mean the linear is x minus plus something or 2x plus minus something. And so then you use a constant, right? So it's the degree is less. So linear, the degree is less, it's a constant. So if it's the quadratic, then the 1 degree letter is linear. So that's why you use ax plus b here. All right, so we did 4 problems here. We have not solving try to take the integration yet. So this 4 problem, just let's try to get familiar with what is the partial fractions. All right, and then the next video we're going to talk about is how do we physically start to evaluate that. Okay, so we're going to have a few problems so we can take a look. All right, that's it. And so I guess I will talk to you in our next video, and let's physically carry out this integration by using the partial fraction methods here. All right, you have a good day. Talk to you later. Okay, bye-bye.